Hello everybody, finishing off our work with section 7.4 here. Let's talk about an application, a uniform motion problem. And in this particular kind of problem, the one thing we're interested in is the fact that we can use a rational expression to help us work with the relationship that distance equals rate times time. However, in this model, we're going to use the fact that time can be found by taking distance dividing it by the rate. So here's the problem. A plane can fly at a rate of 215 miles per hour in calm air. While traveling with the wind, the plane flies 750 miles in the same amount that it took to fly 540 miles against the wind. So let's find the rate of the wind. And if we're asked to find the rate of the wind, of course, we should give that a variable. So let's call it r. Let r equal that rate of the wind. Always name our variable first. Okay, so we're going to set up a little table right here, and I think this is should be familiar to those of you who remember this from chapter 2 and chapters 4 when we did all of this. This time we're going to have distance, we're going to have rate, and we're going to have time, but in this case the relationship that we want is the one that divides distance over rate. Okay, so we have two parts of our trip. We have a trip that gives us flight with the wind, and then we have a flight that goes against the wind. And so we're going to substitute in our values right here. We know that flying with the wind, the plane flies 750 miles in the same amount of time that it took to fly 540 miles. So we've got 540 miles, but equal times. Now, what is the rate? Well, if we're flying with the wind, we know that the plane in calm air might go 215 miles per hour, but for our purposes, we can say that the rate is that 215 miles per hour plus whatever the rate of the wind is, right? It would make sense. The rate of the wind is blowing the plane along. If it's going against the wind, however, it would go its normal 215 miles per hour minus the rate of the wind. Okay, so how does that help us? Well, that means we actually have two pieces of our information. We've got 750, the distance divided by the rate of 215 plus r, and we have the distance that the plane flies going against the wind of 540 miles per hour, divided 540 miles divided by a rate of 215 minus r miles per hour, where again we're taking away the rate of the wind as we blow into the wind. So what is this? This is a T1 equals T2 kind of problem, right? The times, we're talking about equal times, right? The same amount of time. So we replace it and we have a rational equation. 750 when divided by 215 plus r is equal to 750 is equal to 540. Let me try that again. 540 divided by 215 minus r. All right, so these two quantities right here, they're equal, right? That's supposed to be an equal sign. Trust me, it's an equal sign. Just not a very good equal sign. Let's try it again here. Okay, so what do we do about that? Well, this is the kind of equation where we multiply both sides by the least common denominator. In this case, our least common denominator is the product 215 plus r times 215 minus r. So we could write 215 plus r and 215 minus r times our quantity on the left, 750 over 215 plus r, would equal 215 plus r times 215 minus r times 540 over 215 minus r. 540 over 215 minus r. Now, as you can see, what happens is that we cancel out the relevant pieces here. So 215 plus r cancels with 215 plus r. 215 minus r cancels with 215 minus r. And we actually have this equation now, and I'm going to write it over here, where I've got a little bit of room to work left to right. 750 times the quantity 215 minus r will equal 540 times 215 plus r. Now, you're looking at those numbers and you're going, oh my God, those are very big, large multiplications, and if I'm not using a calculator, now what? Well, in this case, you can actually save yourself a little bit of time, right? 750 and 540 are both numbers that are divisible by 10. And if you divide both sides by 10 right away, you get rid of that extra zero hanging out at the end of these things, so your equation looks more like 75 times 215 minus r equals 54 times 215 plus r. And that's good for us because that saves us a little bit of extra time in our work. Of course, we can use all the extra time that we need here, especially given the way that we work on tests. So let's try this out. What would we get? Well, I'll tell you another time saver right here. Let's try this. I would distribute 75 to both numbers, but I'm not actually going to multiply 215 times 75. Why waste the time? We can actually end up reducing this a little bit, and I'll show you how in just a minute. So we're going to take 75 times r here when we distribute. Similarly on the right, 54 times 215, whatever that is, going to end up being plus 54 times r. All right. So what I did right here was that I added 75r to both sides of my equation, plus 75r here, 75r, there we go, and I subtracted 54 times 215, whatever that ends up being, from both sides. So 75 minus 54 times 215. All right, so you know what happens. On the right-hand side, of course, these things just go away. On the left-hand side and on the right-hand side, these just go away. So now the question is, well, what do we do right here? Well, I know on the right-hand side, if I take 54r and I add 75r, I've got a total of 129 r's. Get it? It's because I'm adding 54 plus 75 and getting 129. Well, what about this business? Don't I have to multiply this all out? Well, yes, except we have 75 215s, and we're taking away 54 of those 215s. What's 75 minus 54? You got it, right? Take away the 1, take away the 5. We've got 21 215s, and that's a little bit easier for me to handle. Why? Well, 215 times 21, I carry down 1 times 5, 1 times 1, 2 times 1, and I take 5 times 2, I'll leave a 0 right here, placeholder, 5 times 2, which is 10, carry the 1, 1 times 2 plus 1, that's 3, 2 times 2, that's 4, and I actually have the number 4,515. So right now, looking at my calculation below, I actually have the number 4,515 equals 129r. Now, I know those don't seem like friendly numbers, but it's a lot friendlier than having to multiply 215 times 75 and 215 times 54, then subtract the difference, which would take you a lot longer. So it's a nice little trick to know. All right, what's next? Well, of course, we have to divide by 129 on both sides. Dividing by 129 here is going to give me, let's see, 129. We want to divide that into 4,515. Hopefully it'll be a nice even number. Let's see what we get. Let's see, 129 to 415. Well, I know 130 could go into 450 about 3 times. I know that because 150 goes into 450 exactly 3 times. So let's try 3 here and see what happens. 3 times 9 is 27. Carry the 2. 3 times 2 is 6 plus 2, that's 8. 3 times 1, that's 3. Yeah, 129 would be way too much right here, and we have to subtract. When we subtract that out, we get 64 right here, and then we bring down the 5. How many times will 129 go into 645? Well, I notice that the number ends in a 5, and so my only possible choice right here is if that ends in a 5. Let's see what happens. 5 times 9 is 45. Okay. Put my 4 here. Carry 5 times 2 plus 4, that's 14. Looking good. Put the 1 right here. 1 times 5 plus 1 is 6. Subtract that away. Guess what? We have a 0 remainder, folks, so 35 is equal to R. Boy, that was a lot of fun, but let's see. What is our actual answer? That means that the rate of the wind is going to be blowing at 35 miles per hour in this problem. And we're done. Good luck.